Does everyone see quiz 8? So I don't know if it was her intention, but it's 9:35 to 9:53, but it's a 10-minute quiz. So yeah, just be aware you have like 10 minutes instead of like 15. Yeah, I did look at the questions. It does seem pretty doable in like 10 minutes. So okay. So let's get started. So if you recall from the integral test, which is for positive terms, by the way, right? So your series has to have only positive terms. You get this result, right? So this is called like P series, right? I mean, if you forgot, you could always integrate, right, and check it, but you know, like might as well just memorize this. So there are two other tests we know, and it's based on, so basically, what if you don't have this, but like sort of like things that behave like this? So then you need a way to compare them, and the method here is direct comparison test, right? Like let some an some bn series of positive terms. So again, the terms inside have to all be positive for this to hold. And you basically get two things. So if some bn converges and an less than or equal to bn, then some an converges. And two, if some bn diverges and bigger than or equal to bn, then some an diverges. I wouldn't really, you know, think, I mean, you could memorize it, but I think the better way is to like, think of like follow follow the leader. I feel that's better. So think of the leader as the bigger one, right? So if you're playing like follow the leader, and think of converge as like the leader stops, and diverge means the leader just keeps walking, then like you can sort of see it immediately. So if the leader stops, right? If the leader's walking, this is the leader. It, it, suppose the leader stops here and you're following this person, you have to stop, right? Or else you will crash into this person. Agree? So the idea is if the big thing converges, the small thing converges, right? The small thing cannot go off to infinity, right? Because you're smaller, and the bigger one just reach the finite number. And similarly, right, the second thing is basically, you know, is saying you diverge, so you just keep walking forever. But in order for, to not crash into the leader has to then keep walking forever, right? Because if the leader cannot stop and you cannot just keep walking forever, or else you'll crash into the leader. So basically, this thing is saying, if the small thing goes off to infinity, the big thing has to, right? I mean, it's only natural. So is everyone clear on this? So I wouldn't really memorize this. I think it's more easy to see by just thinking like big, small, or like if you like follow the leader. So one example would be, we have some. So this thing, right? It behaves like 1 over n cubed, right? So what you say is, okay, well, the 8 makes my denominator bigger, which means my whole thing becomes smaller. So if I remove the 8, I just get this, right? But then this thing converges by p series, right? Because p is 3, and we get that it converges for p bigger than 1. So now you just think of it this way, right? If this thing's bigger, so the bigger thing converged, so the smaller thing has to converge, right? So the leader stopped. So the person following the leader also has to stop, right? Or else they will crash into the leader. So here, this thing converges by direct comparison test. Everyone clear? If you like, it's part 1. Yeah. So the 1 over n cubed is bn, 1 over n cubed plus 8 is an. Okay, and the same holds for, the opposite, so part 2, right? So an example of part 2 would be like sum n equals 1 to infinity, 1 over root n minus a half. And here, right, again, the 1/2, when n goes off to infinity, it doesn't really behave, it doesn't really affect anything. So this thing behaves like 1 over root n, right? And if I subtract, I make the denominator smaller. So the whole thing's bigger. So this is actually bigger than or equal to just 1 over root n, right? Everyone agree? Because this thing is a smaller denominator. So from here, right, this thing is just sum n equals 1 to infinity, 1 over n to the 1/2. And this diverges, right, by p series. Because p is less than 1, it's a half. So now you think of it, right? This the one that diverges is a small one. So if the small thing goes off to infinity, the bigger thing has to, right? Because you're bigger. So this thing diverges by direct comparison. Are everyone good with this? Or everyone comfortable? Yes, no. Okay, so let me just say, there are times where if you can use the next test, you can use the previous one. It's just the argument's harder, but I really suggest you use the next one over this one. So the idea is, like, what if instead of +8, like the previous thing, I have a -8 instead? You should still expect, it to behave like this, right? So it converges, right? But if you try to use direct comparison, like the, you know, the in the most obvious way, I guess, this would actually not work because this is bigger than or equal to, right? And so from here you get that this converges, but does that help you for direct comparison? So here you know that the small person stopped. Does that mean the big person has stopped? So if you're following the leader, and let's say you stop here, there's no reason why this person has to stop, right? This person could still just go off. Can just like keep walking, So here you encounter a problem. So it can be fixed using direct comparison still, but the easier way would be to use limit comparison. So let me just, so it will solve like cases like these. So, and in fact, I suggest you use limit comparison anyway, most of the time, since you all know how to take limits. So this is for some A and some Bn positive terms. So basically, it's saying if limit n goes to infinity, an over bn is L, where L 0 less than L less than infinity. So L is finite number. So again, L is certainly positive because these are positive, right? So in case you're wondering why it can't be negative, then either both converge or both diverge. So let me just tell you, right, what is your Bn, and it's exactly what it is. So An is the question, the problem question slash problem you are given. And then for Bn, you choose what An behaves like. I'll explain why you do that. I mean, or else this thing will not work. Yeah. So let's go over an example. So let's say my An is this, right? This thing, n cubed minus 8, pretty much behaves like n cubed, right? So I'm saying your Bn should be 1 over n cubed, right? Because n cubed minus 8 and n cubed, they don't really make that big of a difference when you go off to infinity, right? Like 10 million is pretty much the same as 10 million minus 8, right? Let's put it that way. So from here, what do we get? So this is my An, this is my Bn. So the limit comparison says this, right? Let's take the limit. There's that n cubed minus 8 over 1 over n cubed. And what is this limit? What is the limit of n cubed over n cubed minus 8? It's 1, right? And if you go back, that certainly satisfies this. So we get that both converge or both diverge. But we know this converges. It converges by p-series. So it must be both converge, in which case this must converge. Is everyone clear on this? So let's explain why you choose Bn to be what it behaves like. Suppose you chose something that behaves differently, maybe something that grows slower. So like n squared. So n squared grows slower than n cubed. Let's see what happens. When you do this, right, if you compare with 1 over n squared, something that does not grow the same way as n cubed, let's see what happens. What is this limit? And that's not allowed, right? We do not allow a limit to be 0. You see the issue? If you choose something that grows smaller. And same idea for something that grows faster. If you decide to choose, like, I don't know, 1 over n to the 4th instead, by faster, I'm talking about like the denominator, by the way. Of course, if you do 1 over it, it's the opposite. So you get this. And what is this limit? N to the 4th over n cubed minus 8. What is this limit? Yeah, infinite, right? And you see that we also do not allow infinity. So really, you need to choose something it behaves like for the limit to at least have a chance to be like finite, right? Like, because if you're comparing two things that grow differently, one will grow faster than the other, right? In which case, the one that grows faster will win out. So if it grows faster, then then when you divide it, you're either going off to infinity or zero, depending if the faster one's on the top or bottom, right? So yeah, okay. Anyhow, let's continue. Let's do one more example. How about this? So this is my AN. So my first question is, what should BN be? Mhm. The one is irrelevant, right? So this should behave like this, which is just this, right? If you like, it's n to the 1/2. So this is my BN. I mean, sorry, sum of BN. This is my sum of AN, right? And then you just do limit comparison, right? So I'm gonna go faster. So this is AN, and if I divide by BN, that's the same as multiplying by root n. So if I factor the n root n out, I should get 1 plus 1 over n. Yeah. These cancel, and then the limit, you see that the limit's 1. So both converge or both diverge. But we know this thing diverges because P series, right? It's n to the 1/2. So this thing must diverge. So everyone clear on this? Shouldn't be too bad. So you've learned a lot of, I mean, you're gonna learn a lot more, but you learn a lot of tests, right? So let me just, you know, give you the overview and why we consider this next one. So first, you learn geometric series. I think that's pretty obvious, right? You use it if the series is geometric. I think your quiz today is on geometric, by the way. So from here, you have telescoping. This is when terms cancel out, right? And then you have positive series tests, right? Series tests. So basically, you can only use this if the terms are positive, right? So you have integral tests. You have direct comparison. And the thing I just want to limit comparison. Yeah, so what do you think the natural question to consider is now? If I have a positive series test, what's the next natural thing? So yes. So good. but let's think this through. Good. So if my whole thing is negative, if Bn is less than or equal to 0, it's you can technically still use this, right? Because you just do this. Now this, I mean, if this converged, then it converges to negative of this, right? If it diverged, the negative of it will still diverge. So basically, you would just do the positive series test on this thing, right? I mean, this is true for all n. Do you agree? Like if all terms are negative, it's actually really easy. You just negate, and then you use the positive series test. Do you agree with that? So the case where it's all negative is actually not that bad. So what do you think the next case is? If it's not all negative, not all positive, then your next case is it's a mix of negatives and positives. Agree? And the first thing you could think of is, okay, what if it just keeps alternating? Yeah, so an alternating series. So it's a mix of positive and negatives, but in a well ordered way. So how do you make it alternating? Well, you just put -1 to the end. So, and sure enough, if you just plug in n equals 1, n equals 2, you're gonna get this. It's alternating between negative and, of course, Bn has to be bigger than 0, right? I mean, if B1 was positive, B2 was negative, then all you're doing is you're just adding, right? So obviously we need Bn bigger than 0. So in this case, minus . So the first case is to consider a mix of positive and negatives, but in this case you just keep alternating, right? So from here, like, what do we do? Well, I'll go over option 2 next time because I couldn't get to that for the previous class. But option 1, you have the alternating series test. And what it says, oh, by the way, let me say n. So let me just say it could be n. Yeah. N and -1, it doesn't matter, right? If it's n, then it would be negative B1 plus B2 minus B3, but it'll still be alternating. So as long as it's like alternating, you're good. So it says this: if Bn decreasing and limit n goes to infinity, Bn is 0, then sum n equals 1 to infinity. Again, this could be an n, right? It doesn't matter. Converges. So the important thing to note, this is really important because a lot of students just see 1 over n and then they think. So certainly Bn is 1 over n satisfies these two conditions, right? Bn is decreasing, right? And limit of as n goes to infinity of 1 over n is 0. So you get from alternating series tests that this thing actually converges. But as you all know, if I didn't have that -1 to the n, this thing diverged, right? Right, this thing was called the harmonic series. Right. And if you like, this thing is called the alternating harmonic series. So let's sort of see what is going on, right? The first, so the harmonic series, 1 plus a half plus a third plus a fourth. Yeah, so this thing diverged, right? Diverge. But when I do this, right? Let's see what happened, what's happening, right? So you see the alternating series has been saying there is enough cancellation, right? Because Here, nothing cancels. You're just going bigger and bigger. Here, this thing will sort of cancel with this thing will sort of cancel with this, so on and so forth. Yeah. So the idea is when you have -1 to the n, there's like cancellation, right? So it's possible, if this went off to infinity, well, maybe you won't go off to infinity if you cancel enough, right? If terms just, sort of negated each other. So, and then apparently, let me just say, apparently, if these two conditions hold, the test is basically saying there's enough cancellation. You will converge. Does everyone get that, or does that make sense? Yes, no. Okay, cool. So knowing that, we could do an example. I mean, like this is easy because e to the n is increasing. So 1 over e to the n decreasing. Yeah. It's certainly, the limit's certainly 0. And e to the 1 over e to the n is positive. Strictly positive. So this thing converges by alternating series tests. I'll write ALT for alternating. Yeah. So an important thing to note is the decreasing part you have to check, but the limit not being 0, the limit being 0 is sort of a must, because if it's not 0, you're also done. Let me just give you an example of that. Right? If this thing is not 0, yeah, it doesn't satisfy the alternating series test. This thing's pi over 2, right? Like, yes, it doesn't satisfy the alternating series test, right? Because the limit's non-zero. But what other tests do you know? You know a test. So if this is pi over 2, what is this? So what is this? So if this thing is going to pi over 2, the -1 to the n, you're sort of alternating from like things close to pi over 2 to things close to negative pi over 2, right? Kind of oscillating between those, right? Do you sort of see that? So if you're oscillating between stuff, so at one term you're like close to pi over 2, the next term you're close to negative pi over 2, and then next term you're close to pi over 2 again. Next term you're close to negative pi over 2. What's this limit if it just keeps oscillating like that? I mean, should be this, yeah. So if this does not exist, this thing diverges, right? By a test. It's called test for divergence. So I'm saying if the limit's not 0, then test for divergence just kicks in, and then you're also done. So so just because you're checking the hypothesis of alternating series test, and you're like, hey, it's not 0, but then that's not really a bad thing, because then you get its divergence for free by like test for divergence. Is everyone clear on that? So let me just say, option 2, I mean, like, what do you do if it's, option 2 is it involves absolute convergence. Basically, convergence, basically, you take absolute value of the insight, you work with this instead of this. And basically, let me just say, I'm gonna go over this next time, but idea like is this, and why do we do this? Well, if I have a -1 to the sorry, this is like -1 to the n bn, if you like. So if an is like -1 to the n bn, the absolute value of this would just be bn, right? Because when you absolute value -1, it just becomes 1, right? But because you're considering the absolute value, everything is positive now. And if everything is positive, guess what? You can use these three tests now. So the second route, if you see like -1 to the n, is to get rid of it. Take absolute value, use these tests, and then use some theorem relating the absolute value and the original. So that's the idea. So that's like option 2. So option 1 is keep it, use the alternating series test. The second one is, well, get rid of the -1 to the n, and then now we have these 3 tests at our disposal, because when you take absolute value, everything's positive. Everyone clear with that? I'll go over absolute convergence next time. Everyone good? Okay. You have like 3 minutes to study. So again, do note, I think the quiz is 10 minutes. Yeah. So